So hi everyone, super excited to be here. Just going to wait for the screen to come up because today, what I've planned for us today is essentially to go through a GCC model of what Gen AI could look like. And we're going to do some really interesting stuff across supply chain, manufacturing, banking, insurance, pharma, life sciences, auto, to a few other sectors and kind of do a cross of where all Gen AI can be applied. So really excited for today. I'll just disconnect. Okay.
Yeah. Can you put it on full screen? Full screen.
It's done. Yeah. Awesome. So let's get started. We have some fun things planned. So before I start, I actually wanted to, so we have some of the smartest people in the room today from all across India, Bangalore, and I've done this really interesting puzzle about what in the last, I would say, 4 or 5 years, done this little experiment. And it's a very interesting puzzle you need to solve. So once you solve it, just raise your hand. Okay? We'll see how many people, how much time across the room. And if you are raising your hand, we might ask you how you solved it as well. Right? So your time starts now. And the goal is to start from the first arrow on the left, land up on the second arrow on the right. It is a tough puzzle. So time starts. As soon as you solve it, just raise your hand. And we'll see. Okay, 10 seconds in. "15 seconds in. Okay, one solve. We have one person who solved it. 2, 3. 25 seconds. Okay, we have one more. All right, so we've reached about 30 seconds. It is a tough one, to be honest. I would say it is quite a hard maze, especially when you're seeing it from a distance on the screen. But my question to everyone is, did nobody think of just doing this? Or just this? Because if you recall what I said, all I said was, we want to start from the left arrow. We want to reach to the right arrow, right? I never used the word maze. I used the word solve, but I never used the word maze. I never said go through the maze, right? And this brings us to a very, very, very important point, right? And essentially what that is when you're working in business, it's kind of like solving a maze. And we always bring a lot of our pre-built assumptions into the way we solve these things, right? And that somewhere catches us out in the way we work, right? We're busy solving complex mazes when there are very easy or different ways of solving the problem. And this kind of thinking is a very popular approach. It's called first principles thinking, where you start by questioning all assumptions, right? So you literally start at the base, and then you build up, right? And it's that kind of thinking which allowed an Elon Musk to say, why doesn't the rocket engine come back, right? The main booster, why doesn't it come back to Earth? Why do we just discard it in space, right? It's that kind of thinking that allowed Albert Einstein to really change the way the light bulb was invented, right? So what I want all of you to do today is try not going through the maze. I know it's super challenging to run a GCC, to run an operational unit. There's a lot of pressure. But for today's session, let's just think outside the box. I'm going to throw at you guys a little different ways of doing things, some interesting demos as well, to reinvent the way process flows are looked at a GCC. And if you really, really destroy all your assumptions, I think you will have a lovely time. So just a quick, intro or context about myself. We've worked in the AI space for about 14, 15 years now. We work with some of the largest corporates to the smaller ones as well in the AI space. Even before it got very, very exciting, we made it to the cover of Forbes. And it was that journey, right? So I know in my introduction, they kind of talked about how I started out as a chartered accountant, learned coding to build out the firm. In fact, Raghav and me, my co-founder and brother, he got into IIM Ahmedabad, I got into ISB Hyderabad for MBA. But the business was really scaling, so we decided to drop it and kind of continue focusing on it. And it's that journey or experience that I'm going to kind of talk you through in terms of how we look at AI, where we've seen companies achieve massive success by leveraging AI. And this is a really interesting one. So we launched the world's first book written completely by an AI. It was called Bridging the AI Gap. It became an Amazon bestseller. And this launched in October 2022, which was 1 month before ChatGPT came out, right? So the technology of generative AI has existed far, far before OpenAI kind of brought it to the front. I think it's amazing what they've done. But the tech has been there, right? The core transformer technology on top of which this is built has been there since 2017. Generative AI, GPT-1, 2, 3, and some of its other variants, like the open source ones, have been around for quite some time. So it's actually important to note that the tech is not that old. Okay, let me ask you a question. What does this girl need? You can just shout out the answer. Okay, umbrella. Anything else? Raincoat. Okay. Sorry, she wants to cross the road. Okay. More rain. Okay, that's a fun one. Right. So when we're thinking, right, we've said umbrella, we've said raincoat, but when you think in terms of nouns, right, you're thinking in terms of solutions. Right? So these are great answers, by the way. But an umbrella is a solution, right? And when you look at actually solving a lot of these problems, if you take a step back and think in terms of verbs, right, an action or what you want to achieve, we probably would say we want to keep her dry, right? She has a need to be dry. She doesn't necessarily need an umbrella. She could need an umbrella. A raincoat could be a solution. School from home could be a solution, right? If she's going to get something, then an Uber or Uber Eats or a Zomato or a Zepto could be a solution, right? So the solution isn't necessarily always that noun that comes first to mind. And so this is an interesting project that we did. This was back, a couple of years ago, where we kind of applied that same level of design thinking, and I want you guys to apply it to when you look at, how you're approaching AI in your GCC. It was essentially, the problem that we were given was, there was the magazine of the future, right? It was Forbes' 100 years. They wanted to build a magazine of the future. What would that look like? And the thought process was, how can we give the reader an experience that they truly, truly enjoy and love, right? So that's kind of what got us to building what I'm going to really show you right now. But it kind of comes back to that design principles thinking, where you don't make AI the center of what you're solving for, right? So if you're solving for a problem, don't think, okay, AI is the solution, right? Think of the problem, think of what needs to be achieved, and then eventually solutions will come, and AI might be a part of that solution, right? So it's a very interesting quote. It's that when AI is nothing, that's when it's everything. And I'll just repeat that for dramatic effect, but when AI is nothing, that's when it's everything. And that means that when you actually put AI in the background and you actually work on use cases, right, and solve for the problems, and AI is there, but it's hidden away and it's making the magic happen, that's when you've achieved true value for AI in your GCC. So let me show you this really fun example.
I cover. What does that mean?
Well, Warren worked
And I say, I looked at this and I said, what does this mean? First ever AI cover. What does that mean?
Well, Warren worked closely with us and a company called Fluid AI. You take a picture of that cover, and a three-dimensional image, holograph of Warren pops up, and he'll answer questions.
And I say, I looked at this and I
So I'll show you what the experience actually looked like.
Hi, I'm Warren Buffett, and we're celebrating the 100th anniversary of Forbes magazine by answering your questions. Thanks to artificial intelligence, you and I can have a conversation. So ask away. Anything about business, finance, or my personal journey. Click on the microphone at the bottom of the screen to ask me questions.
Warren, what should I invest in?
Invest in yourself. You can't beat it. I see people that can increase their potential 50%, 100%.
So there you have it from Warren, right? You should invest in yourself. Now, what if a 500-person company or a 5,000-person company can behave like this massive behemoth, right? Like a 50,000, 500,000-person company. And this was an interesting case study from Moderna where they said, we're going to deploy AI, generative AI, in every core element of the business. Because they're a 5,000 people company, right? They were one of the folks behind a COVID vaccine that was very successful. But they said, scaling forward, can we be a 5,000 people company, but start to behave like a 100,000 people company? And that's where they're now leveraging AI or looking at AI in interesting ways. And right before we get into the use cases, I wanted to just quickly touch on this key difference, right? Because many times when you're in a room and you're brainstorming on how do I deploy, like, okay, is AI a good solution for this problem that I have? I think having this clarity of the difference between the three is very, very key, right? So we started off with machine learning. That was the age-old technology, right? For the techies out there, logistical, you would have heard was like logistical regression, decision trees, those kind of algorithms. So machine learning algorithms are essentially built on the premise that you're trying to predict something, right? So let's take a bank example. You're trying to predict who will default on their loan, right? And you're predicting loan default. You're basically giving the model, machine learning model data, right? Okay, these are the people that defaulted. These are people that didn't default. And these are their characteristics, right? Age, gender, income, which area they're from, et cetera, et cetera. So you'll run a machine learning model, right? Model will learn from the data. It'll give you a prediction back, right? And decent accuracy. So that was the paradigm we used to be in. It used to also tell you why it's taken that decision, right? Because the model used to be quite shallow. Then someone came along and said, what if we make the model very dense, right? So instead of hitting 70% accuracy, now you're hitting 90% accuracy. But the model is much more denser, so you can't explain what's happening underneath, right? It's a black box. That's what's deep learning, right, essentially. But the challenge that they had was they always relied on high-quality labeled data, which, as we all know, no matter which GCC I've talked to, which big org I've talked to, which small org I've talked to, data is always a mess, right? It's not labeled properly. Bangalore will be written as Bangalore, Bangalore, and some very weird misspellings in the middle as well, right? So suddenly you're running a algorithm predicting based on city, and then suddenly these are being treated as 2 or 3 different cities. So that was the problem most orgs had, right? That's why deep learning, you try to do these predictive problems in your orgs, right? Predicting machine failure, predicting credit default, predicting next best product. It would take you months, right? 3, 4, 6 months sometimes, and you still wouldn't hit success. Because either the data is bad, building the model takes time, you need experts, right? The right model needs to be built. And that's why Gen AI changed the approach, essentially, right? So generative AI is built on the fundamental principle that we don't need labeled data to train an algorithm. It's going to go to the internet, read it. Essentially, it's a next word predictor. So it's learning that, it's reading the internet and learning. But that behavior, suddenly, when you do it at scale, the AI starts to kind of understand a lot more than we humans actually earlier predicted that it would. And those are those interactions that you see. But because these are pre-trained, right, now they're trained from the best techies in the world, right? A Google will train them, a Meta will train them, an OpenAI, a Microsoft will train these. The quality of the models is far better than what teams were able to build locally, just because these are the best engineers in the world. And now they're giving you that entire pre-trained model free, right? In some cases, they're charging you a hefty sum per request. But you're essentially getting this pre-trained model with beautiful intelligence, right? And then you can just deploy it in your organizations and extract value from it, right? And that's the paradigm shift, right? That's where companies have gone from a 6-month, 4-month piloting phase on AI to saying, can we pilot within a week, right? Week, 3 days, 4 days, and really make some cool successes out of it. So before we get into the use cases, right, a quick note on how AIs learn, right? So one of the biggest advantages AI has is that it lacks emotion, perfectly rational. Right? And the biggest disadvantage that AI has is that it lacks emotion and it's perfectly rational. Now, the way an AI learns is through a concept called an error rate. It makes mistakes, learns from those mistakes. The higher the error rate, the better the algo gets later on, right? Because it's learning from its mistakes. Now, when a human goes and makes mistakes, or makes an error rate, what do you think we get when we add a little bit of emotion to the word error rate? What word would we get? Okay, so failure, absolutely, that's the correct one, right? So the minute you add emotion to the word error rate, it's called failure, right? So I think as orgs, when we're deploying AI, we need to really understand that it's not always going to be a success, but it's an error rate. So the bigger the mistake you make, sometimes you're going to be that organization that the next deployment, you'll know everything that's gone wrong and make it a massive success. So let's come to the enterprise GPT, right? Everyone talks about setting up generative AI within their enterprise. And let me take a couple of interesting examples. The first is a document-intensive department, right? Imagine you have a department with lots of documentation, standard operating procedures, manuals, other kind of documentation, old kind of letters drafted, all of this content that's there. And it could be in any format, text, file, PDF, doc, PPT, website. It could even be in a structured system. We'll kind of show you some interesting demos there. You can load now all of that into the generative AI, right? And have this amazing interaction with it, where it's able to get answers to your burning questions as a team, right? I think one of the biggest challenges from folks that run GCCs, that work in GCCs, that have come to me with, is that, Abhinav, we spend 40% of our time trying to find the right process. How do we do this? Who's the right person who has this knowledge, right? Sending out email chains that get longer and longer and longer till we find that one person who says, yes, I know how to do this. This is the document that you had to use. And that document wasn't there in the document management system. It didn't come up in the search of the document management system because essentially these systems are built for keyword search, right? But now if you're running a life sciences pharma GCC, there are going to be, and let's say you're doing diabetes healthcare, then the word diabetes is going to come up millions of times in every document, right? So if you do a simple search of what is the process for this deviation for this diabetes medicine, you're going to get 50 documents which all have interesting information, but you don't know which one has the right one. So let's show you a few quick, interesting examples of this, right? So I'm going to take about 5, 6 different examples. We'll show you live demos of how this interaction actually works, how it can actually make sense. So first one I'm taking up is supply chain manufacturing, right? Any kind of plant that there is, a lot of times GCC support these plants, right? They become the support center for the plant. Sometimes there's tech that they're introducing within the plant. They're also running the operations of the plant. How can we make a GPT for the entire plant such that we solve these goals, right? When a machine goes down, instead of it taking hours and hours for it to fix, people in 3 minutes can fix it, right? How can we solve workers' challenges of knowing what to do in the plant, right? Call up an AI, talk to an AI, and get their problems solved. So let's actually go ahead and show you something. I'm going to go out of presenter mode. So let's say I'm in the plant. Hopefully the internet doesn't play spoil sport. But I go ahead and ask it a question. How does the ignition coil connect to the distributor? And I send it over, right? So I'm at the plant, I'm kind of trying to figure this issue out. And there's tons of documentation, right? There's the machine operating manual. There's a bunch of other Kaizen documents, right? Self-improvement documents of someone in the plant who's seen this issue previously. They might have it in some online system of theirs. And they're kind of trying to figure out this problem. There might be other directors' notes lying over there, right? So it's gone ahead, it's given me the answer saying the ignition switch is connected to the coil generated high voltage electricity, etc., etc. Now what's interesting though here is when I see the sources of where this answer is coming from. It's coming from an electrical drawings PDF, right? It's taken me to that relevant page. But it's actually taken out a diagram from that PDF and given me the answer, right? So this is the kind of search that you now need to be living in a new world, right? It's searching an image, it's figuring out the answer from the image and it's giving it, right? A traditional system never going to come up. And imagine a plant efficiency, right? 200-page manual document. Worker has instantly at any level gone ahead, processed, got the answer, right? And not just from that one manual, but all the plant manuals, all the plant documents. And that's the power we're seeing, right? We're seeing mean time reduction of plant operations, plant failures, plant machinery go down like 10x, 20x. And especially where they're facing these challenges where the old audience or the old plant workers are aging, right? For firms that have been around for years. That audience is aging. They're going to take all this knowledge out of the system. And suddenly you're going to have an operational minefield running at the plant. So let's take the second example now, which is an AI assistant for support functions, right? How can we reduce resolution time? How can we ensure knowledge never gets left or lost in any way? And folks and agents can actually answer questions really efficiently, right? As GCCs, oftentimes we are the support agent for the entire org globally as well, right? All questions, all requests come through the central layer that you guys are. How do you make that efficient? How do you make that 24/7 if it's not already? And how do you let it scale, right? If let's say another capability center in Mexico goes down, your load is going to double overnight, right? How do you handle those situations where it's kind of volatile without changing the SLA that you're aiming towards? So in this one, let's take an example of a bank, right? We're going to go ahead and say, okay, this is a bank. It's kind of the IT team's kind of handling requests that are coming in for any kind of layering. So let's say I'm going to ask it, how do I install and configure self-service password resets? So it's gone ahead and given me the steps. So this could be over multiple channels though, right? So similar to the previous problem, you kind of said, okay, it's gone through the documentation, given the answer. But if you want to take it up a notch, right? So this is kind of all text output, but let's say we want to make it a little more interactive. Can we have the AI, can you talk to the AI, right? Can it just be a call? So we'll take the same example, we'll kind of make it a little more generic, and we'll say, supposing this support center also handles customer-facing requests, right? So it's a credit card support center. We just throw in all the knowledge. Again, knowledge throwing is just uploading all your information as is. So it doesn't take more than a couple of hours to sync data across. And let's see if we can make a call to it.
Hi, how are you doing?
Hi, I'm good. How are you?
I'm doing good. How can I help you?
I was wondering if applying for a credit card will affect my credit score.
Please wait while I check that. Applying for a credit card can have an impact on your credit score. When you apply for credit, the creditor or lender will typically request
And
a
what
copy
are
of
the
your...
fees on the Chase Sapphire Reserve credit card?
I'm looking into it. The Chase Sapphire Reserve credit card has the following fees. Annual fee. The annual fee for the Chase Sapphire
Okay,
Reserve
thank you.
credit
I will
card...
call you back. Right. So imagine people just being able to call WhatsApp or do an email interaction with the same generative AI, right? The power that it can bring at multiple levels is phenomenal, right? Instant, real time, you can interrupt it, it sounds human. And that's all possible because the latest set of algorithms that are now available, right? It's just going to get better. Now coming to the third example, which is shared services, operations. Again, if you take that same paradigm, right, you can actually go ahead and run the same logic there as well, right? Shared services documents, other kinds of information that's available. And then the fourth that I found very interesting is any kind of marketing, sales assistance, content creation assistance, right? Because imagine if you're the back office that's helping, creation of great amounts of sales content, very specific, very complicated content that needs to be created at any point in time, then can we have the AI help us do that, right? So let's take a pharma example now. And I'm just going to ask it, what's the BRDA funding for Novavax? It's going to give me some details. It's going to give me a document as well. And I can just go ahead, say, okay, this looks interesting. So just take some content from here. I'm going to ask you to create a deck, and I'll say, make it formal and interesting. So let's say there's a presentation that needs to be prepared on this particular funding and the amount, right? So I'm going to fire in create deck. It'll go ahead and create a deck and kind of generate the output that's needed essentially. And while it's generating, I think the other use cases that we've seen, which are quite powerful, are essentially, okay, so we have the deck, federal funding for COVID-19 vaccine, and then we have like a table of contents, what's it going to talk about, overview of BARDA, et cetera, et cetera, et cetera. And as you go on, you can kind of see all the relevant information that's there. So these AIs are now becoming multimodal, and that's what's bringing a lot of power, right? Talk to voice, create a deck, create content, but create it relevant to me, right? Don't just use an existing, a fun template, and don't bring in the real knowledge in. My deck is going to be complex, it's going to be 20 slides. This is how I structure the deck, right? That's where a lot of the enterprise GPT part, where you want to customize it for your GCC, really comes in. The last one that I wanted to really talk about, which is a fun one, is HR and recruitment, right? Big challenge, getting good talent is always a big pain. How do you make that happen very efficiently, right? If you're a GCC that's helping with recruitment for the larger organization, how can you make that happen faster? And if you're recruiting for your own GCC, which you always are, and there's always a lack of talent anywhere you go, how do you make that process of efficiently finding folks so that you can make the right decision? So I'm going to go ahead and just switch on an interview agent, right? So in this case, and I'll make it a little bigger, but the agent is essentially, we're looking for a front-end developer, and it's kind of interviewing as if it's a front-end lead, right? So ask me how much experience do I have in front-end development. I'll say about 2 years. Oops. Okay, I think the Zoom is messing it up. What's your preferred coding language? So I'll say JavaScript and React.js. Now what it's going to do is every answer that I give it, it's going to ask me follow-on questions based on that. So it's slightly more evolved than giving a traditional form. And what the AI is doing at the back is it's actually scoring each answer. So it's kind of getting almost like a GMAT style understanding of rating of how good is this candidate, should I up my level of questioning. So if now I've talked about, okay, being 2 years in JavaScript, React, it said, now it's suddenly gone into, okay, responsive design and cross-browser compatibility, right? Have I ever done that? It's a key skill needed. So, and none of these questions are fed, right? They're all generated in real time during the interview. And it's going to give you an end score. It's going to give you outputs of what it thinks the candidate looks like. But that suddenly allows you to evaluate these candidates at scale. And while resume parsing is a great technology, we feel that this is the next step after that, right? So you probably will still want to do that. You might probably want to maybe skip that. But this would become a nice layer of capturing information and getting answers. We now have capabilities available in generative AI that can allow you to create a panel of experts for the interview as well. So you'll get interviewed by a front-end expert. Then for organizational culture, you'll get interviewed by an HR expert. And then for, let's say, generic IQ and coding, you'll get another expert, right? In no way is this going to replace the role of the HR. You still have to do that physical interview. I don't think technology like this is so evolved yet that it can say, oh, wow, I can tell you which candidate is great. But what it's going to allow you to do is your HR team's time is going to get far more valuable because they're going to be interviewing really high-quality candidates, right? We all hate that interview where after the first 10 minutes or 3 minutes or 7 minutes, you realize either this candidate has cheated in a test or this candidate kind of faked his way through the first filter round, or he's written stuff on his resume that makes no sense compared to what I'm interviewing for, right? So it's all about bringing that efficiency in. Now, one interesting thing that I wanted to kind of talk about is when you're setting up a lot of these, right, you're setting up these amazing technologies, you kind of go back and think about a big innovation, right? Something like this. I think it was Elon Musk or Bill Gates, I've forgotten who it was, but they said generative AI is almost like how electricity or the light bulb was invented. Right? And when you look at the light bulb, you think, okay, Edison, great guy, phenomenal work, invented this thing. But if you think about more things, right, like that light bulb alone isn't as exciting, right? It's a nice party trick, but without an infrastructure of a grid, right, an electricity grid at the back, it's quite useless as a technology, right? If you don't have electricity grids and you didn't have back then and you give everyone a light bulb, it's just sitting at home and they're not doing anything with it, right? So that's where the same kind of applies to generative AI, right? You have, the grid is kind of coming up, right? You have LLMs, you have the infra. But as an organization, you also start needing to think of your grid, right? What is my grid for generative AI? Can I set up an enterprise GPT platform? Like we've done it for a lot of organizations where it's a central platform that's there. And then they're saying, okay, now let's deploy, let's do first use case, right? Let's rapidly prototype, see whether it's working. Now let's do another, let's do another, let's do another. So I think it's very important to think of it from both aspects, right? Think of it from a light bulb moment, but also keep thinking at the back of your head what my electricity grid is going to look like. Okay, so we're going to do a fun thing. Just everyone take out your phones. I hope a lot of you are on Instagram. So fire up Instagram and search for this Instagram handle, right? Aisha Neo, it'll probably be as Aisha Aggarwal, but AISHANEO. So she was there at NASSCOM GCC just kind of half an hour ago. She kind of took a photo. She shared it on Instagram. And you can go ahead, like it, follow her. But what I wanted to kind of show with this one is that it's a completely AI-generated influencer, right? And that's a new model that's coming out. And what we're seeing is that the impact that's coming, right, in this next 1 to 2 years is not just going to be at this core enterprise level, right, which is your structured data, unstructured data. It's going to be at every layer, right, whether it's image generation, for those who don't have Instagram. So this is her at the summit today. You probably see her later on in the summit as well. So if you follow her, you'll kind of see her around in different places. But you're going to see this impact hit you if you're a media agency, right? If you're running large-scale digital campaigns, you're going to start seeing these come out in forms of video, in forms of images. Next week, she's going to put up videos as well. So you kind of see the quality that the industry is reaching. But it's going to be massively powerful. And the only other thing I wanted to quickly touch is don't just think of the GCC or this GenAI framework for your unstructured or text data. I know I took a lot of text examples because that's where generative AI really shines, right? Its core was built on text. But let me show you a structured data example, right? So where it really is powerful, right? So if you want to do predictive analytics, right? Predict this default, predict this machine failure, predict my forecasting of my sales, or predict my call center volumes, I would say GenAI probably isn't the solution, right? That's probably a deep learning problem. You want a feed-forward neural network. You probably want a machine learning problem to solve it. But that doesn't mean GenAI can't help you with your data, right? Where it helps really powerfully is you can connect it to your data sources. And when you have that simple question, something like, okay, let's take an example. So supposing I connect it to Snowflake, right? So a SQL database kind of structure on the cloud. And let's say let's go back to a manufacturing example, right? Let's say I have a lot of plant machine data going, right? IoT on my machines, machine data is kind of getting piped to Snowflake in real time. Now, I would have a bunch of complex dashboards I can look at, but I have a very, very simple question, right? So I want to know what are the top 2 machines that failed in 2024 and how many times did they fail? So what the AI is going to do is going to go into real time into that system, figure out all the data, figure out what query to run, design it, run it, and get me the output back out, right? And that output is going to essentially allow me to, oh, we already have it, right? So this one's designed for a technical user. You can design this for a non-technical user as well. But the idea is that it's kind of said, okay, these are the fields I looked at, this is the table I looked at. But you see, the top 2 machines that failed are the boiler machine and the tube filter machine. The boiler machine failed 34 times, tube filler machine failed 7 times. Right? Now imagine walking into a retrospective of the plant 6 months in, and you now instantly know without a dashboard, without some complicated access, right? Which are my 2 troublemaking machines? What do I need to fix? And this isn't just applicable here, right? It could be across your operational flow. It could be data collected across your SAP, ERP, or any other system. So think about both the structured and unstructured side. So I'm just going to leave you with the last thought. This is a framework that we find very, very powerful when you're looking at use cases, because most people get lost in the tons and tons of use cases that they have, right? Should I do this? Should I do that? Should I do X? Should I do Y? So the way we see it work is you kind of have your business value, high business value use cases to low business value use cases, map them out. And then you have feasibility, right? Feasibility could be technical feasibility, operational feasibility of the solution. And then you map that out from low to high on the right. And then suddenly you start plotting all the use cases, right? Oh, we were thinking of automating a call center. Oh, we were thinking of changing the way our shared services does operations. Oh, we're thinking of implementing this in the plant. And once you have that matrix, you just move top to down, right? You start right at the top. Half the time you get lucky, right? By the time you're reaching lower, AI, the way AI and LLM technology is changing on a daily basis, probably some of these low technical feasibilities by next month would have automatically become high technical feasibility, right? You can see the classic example with GPT-4o, omni-channel, it can talk to you, interact. I kind of showed you a version of our Fluid AI GPT that kind of has the same capability. It can run off of any model, but suddenly new use cases have come up, right? So you build this matrix, run it, and then you kind of move. You also look at, when you look at technical feasibility, you see how if your data is very critical, you might need to bring the whole solution on-premise, right? We've done that for a lot of orgs, and we found that it works. There is a little bit of complexity that gets added, so those probably go in the medium feasibility category, right? The minute you're saying on-prem, probably put them in medium feasibility. If you're doing cloud, then high technical feasibility. But it's not to say that on-prem doesn't work. It works phenomenally well, very powerful, and something worth looking at. It's saying time up, so do we have a couple more minutes, or do you guys want me to? Questions? Okay, so let's open up for questions. Yeah, I think that'll be more fun.
Hello. Hi. First of all, thank you. I represent Modernizing Medicine, and I have one quick question. Now that the authenticity of the data, right? Like we work on a lot of medical codes, billing, and CPT codes and everything. So while generating these models and solutions, I'm trying to understand the authenticity when you try to feed the data. What is the correct information? Because it has a patient impact if the generative AI provides a solution which is not like vetted properly.
Sure. No, great question. I think hallucination has always been, a key thing to crack within the enterprise space, right? How do you take that underlying data and ensure the AI is grounded and answering from that, right? Because sometimes AI likes to behave like this student that's answering a 10th or 12th standard exam. You don't know the answer, you try and make it sound as realistic so that you pass. For hallucinations, if my screen's still being shared, okay, it's not there. But essentially what enterprise GPTs typically do really well is they'll ground themselves in the data, and they have these things called a hallucination shield. So even when I was demoing, you probably see a little green tick coming sometimes, right? So that means the AI and those percentages next to each source reference. So that's where the AI is actually, enterprise GPT solutions are built to actually do these checks. We've done a lot of investment at Fluid AI to make that happen as well, where it's going to go ahead and cross-check every answer and only give it to the end user if it's 100% sure that it's coming from your sources. And if it's making something else, it will block the answer in real time.
Hi, Abhinav. My name is Rajesh. First of all, super interesting session. Thank you.
Yeah.
So what you showed, right, when it comes to reading documents, scanning them, reading them, coming up with an outcome, GenAI has leapfrogged with respect to what you can do. How's the same when it comes to doing the same on video content, right? And I'll give you a specific use case.
Yeah.
What we are looking at is, from a marketing branding perspective, what video content works well, what about it, which moment, or maybe a piece of music resonates well, which platform, what's the kind of impression I'm getting, what is competition doing, and so on and so forth.
Yeah.
How mature is it, how evolved is it for practical usage?
Yeah, no, I think great question. What we've seen is, when you look at all this content, right? Like music content, video content, image content. The biggest challenge when you would try to run any predictive model would always be that it's not structured data, right? So you can't run it through any kind of structured model like a neural net or a predictive analytics model. So you would have humans go in and label everything, right? This video was about this video had this giraffe in it, this image has this in it, this song is a peppy song written in rock. What we're seeing for the use case you're talking about is almost like a combination of leveraging GenAI with deep learning or traditional AI, which is you use the generative AI not to predict, okay, like what people will like, but to structure the data. That from minute 0 to minute 60, this video talked about XYZ, then this happened in the video, then this happened in the video. This song is a rock song, this genre, English, country, etc. This image has these 3 parameters, right? It's about, you know, this hair, like this hair brand is being sold, the actor is, you know, from this ethnicity, etc., etc., etc. And then you feed that data to a deep learning model to say, okay, now do very high quality predictions. That's typically how we've seen companies leverage GenAI to solve that predictive problem. And the quality goes up massively.
Thank you.
Thanks a lot for the interesting session. So what I was interested in knowing is that what is the next level of Gen AI now that it is becoming a norm and all the industries, all the organizations are pretty much looking ahead in adopting it further. What do you think, how can we get a competitive advantage using the next level of Gen AI?
Yeah. So I think 2 things to your question, right? Where we're seeing the future ahead is towards almost like agentic models, which basically means that they're a little more advanced. Like we have a lot of stuff here now that says that, okay, if I want to do X task, then almost a team of AIs come together and you know, solve it. So there'll be, let's say you're doing a research and planning job, right? So there'll be a supervisor, there'll be a content researcher, which will look to your internal data. There'll be an internet researcher who will look through the World Wide Web. There'll be a document writer, there'll be a presentation creator. So these 4, 5 AIs will come together and solve your problem. So you'll almost, like what we're doing, we're going into like a GCC or a brand and saying, okay, give the problem, we'll build this agentic model, and then it'll give you the end right from start to beginning. So I think that's a big trend we're seeing. For your second question, how do you kind of make it a success? There's this very interesting story that, you know, these 2 buildings are there, very iconic. There's the Guggenheim Museum, and then there's the Sydney Opera House, right? Both amazing buildings, phenomenal in terms of quality. So the Sydney Opera House was 10 times over budget in building. Took 8 years more than it was planned to finish it. And the Guggenheim Museum was built almost, I think, 5% under budget and on time. The difference was approach. So in the Sydney Opera House, they held a competition saying, best architect to build a drawing, we'll go ahead, commission them. So someone sketched that beautiful sailboat design, started making it and realized, oh my God, this is a mess. It's like very complicated to build. The Guggenheim said, we'll give the award to the best architect, not the best design, right? They used the architect. What he did was he took up a room, kind of like this size, built a cardboard version of it, very small. Then 2 weeks later, built a bigger version, changed a lot of things because things weren't working. Then built a bigger version. Almost had a version that there was this big as a demo. And then said, now let's go ahead and build it. We worked out all the kinks, we figured out what works, what doesn't work, went to work. So I think the same approach needs to be used with AI, right? Do a lot of experiments initially, prototype very fast, right? Almost do like 8 use cases. 4 will work, 2 will be okay, 2 will be failures. Learn from those, and then iterate quickly and say, okay, let's double down on these 4. Let's look at why those others failed. Can we resurface them? Should we look at some other use cases? But once you do that, right, deploy, fail fast, learn, you will be in a far better position than a traditional approach of saying, let me set up this massive, beautiful organizational AI plan, and then I'm going to implement it. And suddenly some LLM company comes up with a massive announcement, your plan is kind of out the window. So that's the approach I would suggest.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.